Hello, is that my stage cue? Lovely, welcome everyone. Just a quick mic check. Can everybody hear me at the back?
Yes.
Yeah, the front?
Yes.
Amazing. Well, now I know two things about you. Well, first of all, that you're still awake, and second, that I can ask you questions, which is amazing. All right, so let me quickly introduce myself. My name is Jan Molak. I'm the lead developer of Serenity JS and a contributor to the Screenplay Pattern. I'm also a co-author of BDD in Action, second edition, together with John Ferguson-Smart. In my day-to-day work, I train and consult with teams around the world, help to introduce modern software delivery practices like behavior-driven development or advanced test automation. Now, what I really love about this work is that I get to see and study challenges that are common across companies and across industries. More importantly, I then look at things that work and patterns that help teams to overcome those challenges. I also create open source tools such as Serenity JS that capture many of those solutions and make them easier to implement. So today I would like to talk to you about some of those challenges that I see, the patterns that help to address them, and how Serenity JS can make introducing those solutions easier. Now, what I'd like to focus on in particular is this idea of blended testing, which is a new approach to test automation that might not only help you write faster and more reliable web tests, it could also help you improve collaboration and foster a culture of quality within your teams and companies. And the reason why I'm really excited to be here in person in Chicago and at the Selenium Conf is because of this passion that the Selenium community has always had for, not just for test automation, but for collaboration and for helping people create quality software. So thank you again for having me. All right, so what is blended testing? Blended testing basically means designing automated acceptance tests that interact with multiple interfaces of the system under test, and not just the user interface. Now, there are many reasons why we'd want to do that, but the main one is to increase their stability, reliability, and performance. However, doing so without reducing their functional coverage. Now, that's the caveat. Now, if you think about it, it feels like a natural solution to the problem of slow and flaky end-to-end tests. Perhaps instead of performing all the interactions through the most unstable and difficult to integrate with interface, the user interface, well, perhaps you could perform some of those interactions through other, faster and more reliable interfaces, like the REST API, for example. So, question for you. Have you ever tried making your UI tests interact with APIs as well? Any of you? Lovely. So many. Perfect. So in this talk, I would like to focus on blending UI and API interactions. But the approach I'm about to show you is general, and you can apply it to other interfaces as well. I'll also share with you some of the patterns and suggestions and how to do that without reducing test coverage. On the contrary, I'll try to show you how to increase it. Now, even though blended testing as a general approach might seem like a rather straightforward idea, well, what's so difficult about it, right? I just make a REST request from my UI test. Easy peasy. Now, the trouble is that implementing this successfully can be quite challenging. Now, to understand how to do blended testing well and to avoid the pitfalls, let's first have a look at what some of those common issues and challenges are. Now, from what I see in my consulting work, most challenges stem from how we approach test automation in general. Well, the first common problem is what I call a tool-centric automation. So let's talk about how picking the best tool for the job can actually get us in trouble. Now, typically when implementing end-to-end tests, we focus on a single interface. Well, the most obvious choice is typically the web interface. So we will take a tool like Selenium or Playwright or Cypress, and we'll create a UI test suite. Right? Makes perfect sense. You take a UI tool, you make a UI test suite. Easy. Sounds reasonable, right? Now, can I have a quick show of hands? How many of you have ever implemented a UI test suite this way? I know I have. Exactly. We all do. Now, The trouble with this pattern is that most systems have more than one interface. So what happens when we need to automate interactions with REST APIs, for example? Well, we will follow whatever worked for us the last time. We will take a REST integration tool this time, and we will make a REST test suite, right? That is completely separate from the UI test suite, that doesn't reuse any of its code, and is completely duplicated. Has anyone ever done that? Often, it might not even be us doing it. Quite frequently, I see companies have separate teams maintaining separate test suites for separate interfaces, which is completely crazy. Now, the problem with having those multiple separate test suites, each using what seemed to be like the best tool for the job when considered in isolation, and a good idea in that case, well, is that more often than not, those integration tools are highly specialized and typically incompatible. So the code we've written for our API test suite can't be easily reused in our UI test suite, and vice versa. Well, have you ever tried using your Postman collections in your Selenium test? That won't work, right? They're two specialized tools, both very good. And of course, the more complex systems we have, the more interfaces we have, the more incompatible tools we introduce, and the more separate test suites we have to maintain, not to mention that many of those test suites implement tests of similar, if not the exact same functionality. There are only so many ways you can register a user, right? Now, this then leaves us with a dilemma. Well, we either stick with this pattern and bear the cost of maintaining all the duplicate test suites, or perhaps even spin up those specific teams and look after those different test suites now on their own, or we could just ignore all those other interfaces, but then we risk poor coverage and escape defects. Well, not a pretty picture either way, right? But don't worry, if that's the situation your team is in or your client's team is in, perhaps by the end of the talk you might have an idea for a solution. So on the opposite side of the automation spectrum, we have what I call the UI-centric end-to-end automation. Again, in theory, it might seem like a good idea. The logic behind it typically goes something along those lines. Well, if it's not possible to test every single possible interface, well, okay, it's not the previous way we saw. If it's not possible to maintain all those incompatible test suites at a reasonable cost, well, we must then pick our battles and focus on those parts of the system that present the most risk. So those parts that the user interacts with the most. Which part is that? Well, the UI, obviously, right? And like the old saying goes, we want to test like the user would. Now, since the user and our business sponsors care about what they see, and what they see is the UI, what we typically do is we pick a web integration tool, we build a UI test suite, and yes, while the UIs can often interact with other parts of the system indirectly, well, of course, they will talk to some APIs, they will talk to a WebSocket every now and then. From the point of view of the web scenario, those interactions are accidental, right? They are side effects of us doing something with the UI, rather than the direct focus of the test. So we might sneak in a REST API call every now and then from our web integration tool, and all web integration tools support performing web requests. WebDriver IO, Cypress, Playwright, they all do that. But again, this is typically on an ad hoc basis rather than a part of a methodical approach. Not to mention that UIs hardly ever interact with all the interfaces of the system under test. So we're bound to lose coverage with this approach by going through the web interface alone. And interacting with the fully assembled system with all its components through its slowest and most difficult to integrate with interface, the UI, is problematic anyway. Because when things go wrong and our tests fail, it's very difficult to figure out why they failed, what component in this whole network has failed. Now, unfortunately, if we're trying to regain the lost coverage by introducing additional API integration tools and additional API test suites, we're back to square one, right? We end up in the exact situation we saw earlier. Right, so it looks like the UI-centric automation is not the best idea, but I'm sure you knew that already. Now, if you think about it, the whole concept of testing the system like the user would is perhaps a little bit misleading. Now, I will tell you a secret. Users don't want to test our systems. They don't care about the UI, they don't care about the API, and what absolutely breaks my heart, they absolutely don't care about the tests. What they care about instead is if those systems that we produce, if they help them to accomplish their goals, if they help them to perform their tasks. All those APIs, UIs, mobile apps, those are technical details, they're implementation details. People don't care. Now, if our systems don't support their goals, don't support their tasks, our customers, our users will just go to a different system that supports them. So this observation got me thinking. To do blended testing well, or I would even argue to do any form of software development well, we must focus on our consumers, on the end users. So we must take a user-centered design approach to test automation, to help us focus on our actors. So all those people, all those external systems interacting with ours. We must look at who they are and the roles they play in our system, so that we understand who we are building our system for and what needs they have. We must then look at their goals. So what they're trying to accomplish and why. Now, this is to gain a better understanding of the purpose of our system and the value it brings to our organization. Not to mention that understanding the value that the system brings or that a given feature brings can help us to prioritize our testing work much better. Now, we must think about the tasks of our actors. So what steps do those actors need to take in order to accomplish their goals and in order to fulfill their role? And only then we should look at the exact low-level interactions that they need to perform to complete those tasks. Now, we need to treat interfaces that they do it through as not the object of our testing, as not the main thing that we are interested in. We need to treat it as an implementation detail, as an interface that people interact through to gain something with the system. So as soon as we do that, observe that as soon as we introduce this additional level of abstraction, as soon as we shift the focus away from integration tools and to actors and their goals and the tasks and their needs, you'll notice that we'll be able to safely mix the interfaces that we interact through, as long, of course, as the interactions accomplish the same outcome. For example, if our test scenario required the actor to start with the system in a certain state, we'd think of it as an actor performing a task to populate the product catalog or register customer accounts, set up the test data. Since the outcome of this task is for the data to be in place, do we really mind how this data got there? Well, if we don't, well, then perhaps we don't need to do it through the UI. Now, if we don't really mind how this is done, only that this goal is accomplished, well, then perhaps we can replace UI interactions with API interactions or interactions directly with the database. Now, of course, if the point of the scenario was to check if the admin person can add product through the admin UI, then fair enough, we would implement that interaction through the UI. However, all the other scenarios that just need the data could just use the API interactions instead. And replacing UI interactions with API equivalents might lead to faster and more reliable tests, especially when all we do is just data setup or manipulating the system state. The only trouble with this approach is that building this sort of multi-modal test automation frameworks to support this way of working and allow you to swap out UI interactions for API equivalents or database equivalents or mobile app equivalents, this is really hard to do. It's really time-consuming, unless, of course, you have the right patterns and tools in place, which is what I'm about to show you next. So let's talk about that now and see how Serenity.js and the Screenplay Pattern could help you build such frameworks and implement blended testing in a scalable way. Question. How many of you have ever heard of the Screenplay Pattern? Right. More and more with every conference. Lovely. Now, Screenplay Pattern is an idea that originated with my colleague, Anthony Marcano, some time ago. In summary, you could describe the Screenplay Pattern as a way of using your domain language to implement test scenarios, but doing so in code. So what you do is you make your test scenarios model the tasks that the actors need to perform in order to accomplish their goals. You already know this mental model. So you turn your scenarios into mini screenplays that describe how those actors go about their work, go about their jobs. Now, the word screen in screenplay has nothing to do with the computer screen. Now, just like the term actors the term screenplay comes from the metaphor of a stage performance. In this pattern, screenplays describe how actors interact with the system under test and with one another. Now, I believe that the best way to explain anything is through a practical example, so let's do that now and have a look at some code. Now, consider for a moment that we are working for an online grocery. It's nearly lunch, so we can talk about some food. Why not? And we need to implement the following test scenarios. Well, I express them in Gherkin because that's what many of us use in our daily jobs, but the approach can be used with any other test runner as well, like Mocha, Jasmine, or Playwright Test, or anything else, really. Now, our example scenarios concern 3-for-2 deals. So, they go like this. Given a pack of apples costs $2.50, and there's a 3-for-2 deal on apples, when the shopper wants to buy 3 packs, then they should be requested to pay $5. And another scenario, same beginning, apples cost $2.50, there is a 3-for-2 deal, shopper wants to buy 2 packs this time, they should still be requested to pay $5, but they should also be reminded about the 3-for-2 deal that they might be missing out on. Now, as you might have guessed, our business sponsor cares greatly about the system supporting this functionality, probably because they have a large stock of apples and they don't want people to miss out on the promotion and the apples to go to waste. Now, instead of jumping straight to the UI and try to figure out what is the XPath selector I need to use to interact with the right thing, or the latest and greatest API tool or AI tool that could generate the tests for us, let's do something different and a little bit more productive. Now, Screenplay Pattern is an actor-centered approach. So let's try to identify the actors we have in this scenario. And this is an exercise you can do with any other test scenario that you work with on a daily basis. So what are the actors here? Well, actors are people and external systems interacting with the system under test. All scenarios have actors, and actors play roles. So what roles do we have here? Well, the role of the shopper is quite obvious, right? I mean, it's staring us directly in the face. It's here in the scenario. To define an actor playing the role of a shopper in Serenity.js, we would write an actor called shopper. Yeah, it really is as hard as this. It's fairly straightforward. Now, and this way we would get an instance of an actor to do what a shopper does. Now, what does a shopper do? Well, in this case, the role of the shopper in our domain is to find product of interest, manage the basket, and make a payment. But the shopper is not the only person in this screenplay. She's only concerned with finding the products of interest and checking if she's billed correctly. She doesn't manage the stock of apples. She doesn't configure promotions. She doesn't have access to any of that in the system, normally. So why should our test scenario model the whole thing as being performed by a single user? They never are. This is a role of somebody else, somebody who manages the shop, perhaps. Now, the role of the person who manages the shop is clearly different from the role of the shopper. They use different permissions, they use different parts of the system, they have different needs, they have different goals, they perform different tasks. Now, if they are different, why not create a new actor? In this case, we could have both a shopper and a shopkeeper. So, what does the shopkeeper do? Well, in this case, they manage the store, they decide how products are priced, what deals we have, and what those deals apply to. Now, in Serenity.js, actors are general-purpose constructs. They can interact with any interface of the system. But at the same time, they are not bound by any interface. So they have no dependency on any specific integration tool. You can use them to interact with UIs, with APIs, with mobile apps, anything a Node.js program can talk to. And general-purpose constructs, like actors, all come from the Serenity.js core module that you can see imported at the very top of my script. OK, so now you know that the Screenplay pattern, in the Screenplay pattern, actors play a role and perform a task to accomplish their goal. But what goals do they have? What are the goals of the shopkeeper? Well, based on this scenario, the goal of the shopkeeper is to set the price of apples at a certain value, a certain amount, and then enable a deal. The goal of the shopper is to find apples, check price, check missed deal suggestions. So that's how we could think of this scenario. A scenario is not a collection of calls to low-level WebDriver APIs. A scenario describes what actors do in our domain. Now, apart from writing this as comments in our code, do you think it would be cool to implement our tests using the same language? Now, turns out that we can, and that's exactly what Screenplay Pattern is about. What we do is we design those test scenarios to model what tasks the actors perform in our domain and how they accomplish their goals. And we name those tasks after the goals they accomplish. So we have set product price, we have enable deal, we have find a product or verify missed deals in your basket, and so on. So that's the mental model we can use. Now, why do we call those functions those names? Those function names help to capture our domain vocabulary that is specific to our company, to our domain, to our product. They make a test scenario perfectly readable and easy to understand, even if you haven't used Serenity.js before, even if you haven't heard of the Screenplay pattern, even if you don't know JavaScript. You can read this scenario and you know exactly what is supposed to be done, right? Now, the cool thing about this is that business sponsors can actually read this code as well, and they can understand it. Now, in the domain of a healthcare application, you'll see tasks talking about patient records and managing doctor schedules. In the domain of an online bank, you'll see tasks talking about managing an account or making payments or making transfers and so on. Those functions are something that your team comes up with to describe your own domain. And with Serenity, it really is as simple as defining a function, which I'm going to show you how to do in just a second. Now, what is really important to mention first, though, is that when doing multi-modal blended testing, we should keep the names of those tasks pretty high level and focus on our business domain. So we don't talk about clicking on buttons, we don't talk about using the login form or sending a specific request. Why is that? Because we don't want those tasks to be constrained by the limitations of a specific interface. Now, using those high-level domain-specific names, it also leaves us with more options to choose from when we want to integrate with this specific interface of the system under test, or to swap one interaction for another that accomplishes the same result. And having options, so not limiting our choices too early, it has a lot of value, as you're about to see. So let's talk about implementing tasks now. Now, so far, all the names of those tasks that we talked about were rooted in your business domain and agnostic of the underlying interface implementation. However, at some point, we must somehow integrate with the system under test, right? At some point, we must click this button. We must send this GET request. So to do that, again, Serenity makes it quite simple. Now, no matter the type of interface that you want to integrate with, to define a task, create a simple, reusable function like setProductPrice, and make it return a task where actor does something. What are tasks? Tasks are just composites of other activities. So they can be composites of click, and I think my mic was set. Oh, I'm back. Hello. So they can be composites of sending requests to API, can interact with. Is this down? All right. Like a proper flaky test, huh? All right. Now, every Serenity.js is a composite. Did I break it? Never let a tester use any technology to just break it. Now, every task is a composite of activities. So by choosing the appropriate activities, we define how a given task needs to be performed. Now, apart from this sequence of activities, a task also has a description. Like in this case, actor sets price of product to a price. And those descriptions are then used to produce test reports when your scenarios are executed. But let's go back to our shopkeeper. Now, since our shopkeeper does data setup, if it's down, just wave at me and I'll try to do stuff with the cables, turn it off and on. So since our shopkeeper does data setup, there's no need for them to do so via some admin UI of our hypothetical online grocery. Now, assuming the admin UI talks to some admin API, well, as they often do, it's much more efficient to use the API directly instead. Now, Serenity provides a number of modules to help you integrate with popular interfaces, and you can make your own integration modules if you wish. One built-in module that you might want to use is called Serenity.js REST. And you can see it imported at the top of the screen. Okay, all right.
Oh, perfect.
So,
All right. There you go.
thank you.
Sure, screw it in too.
Okay,
Just the.
let's work. Yeah, I know. It wasn't me, all right. I'm sure it was. They're just being nice. Okay, so what do those Serenity.js modules do? So Serenity.js core provides all those general purpose things like actors and tasks and interactions and all the APIs to help you build a screenplay pattern scenario. Other modules provide you with interactions that help you integrate with a specific interface. So you have Serenity.js REST or Serenity.js Web, and they give you those interactions that you can compose into your test scenarios. In this case, Serenity.js REST module provides the interaction to send a post request. So that's exactly what we use in our task. We make a shopkeeper set the price of our hypothetical apples by sending a post request to an API. Now, of course, a Serenity.js task can be composed of as many or as few activities as makes sense in your domain. Now, a common pattern is to mix into our tasks some verification interactions from the Serenity.js assertions module. Here, I've added an interaction to check that after sending the request, the response I got back has a status code of 200. And you can add as many or as few activities as you need. Now, since those Serenity.js tasks are designed to be reusable, it's very easy to embed them in other higher-level tasks and reuse them across test suites to avoid code duplication. Well, I'm sure you can easily imagine how a task to set product price, defined like this, could be used by any test scenario that needs some products to be in place and doesn't necessarily care how those products got there. Now, you might have noticed earlier that I used two words to describe the different activities that an actor can perform. I was referring to them as tasks and interactions. So you already know that tasks model the things that actors do, and they're composites of other things. So what are interactions? Well, interactions like send are the low-level activities that actually interact with the system. So in Serenity, you'll have interactions like send a request, or click on a button, or enter a value into a form field. And again, you can always add your own interactions if you are so inclined. Now, how do those low-level interactions work? Because you remember I told you that this whole model is to help you decouple from the test integration tool. How do they actually work? Now, in the Screenplay pattern, we have a concept of abilities, and you can see that on the left-hand side. Abilities are what enables interactions to work. You can think of them as wrappers around integration tools. Like here, for example, I have an ability to call an API, and this ability to call an API wraps a HTTP client, the Axios, which is a popular one in the Node.js land. Now, those interactions, like send, they look for a specific ability, and then use a method on an ability to perform the interaction. It's pretty simple. Now, abilities decouple your scenarios from any quirks of the underlying integration libraries and enable a standardized interface across various integration tools that provides similar kind of functionality. For example, if you wanted to use a different HTTP client, you could swap out the built-in ability to call an API and provide your own implementation, wrapping your own client. That's not a problem at all. Now, the mechanism of Serenity.js abilities has another characteristic interesting in the context of blended testing. It allows you to create alternative implementations of the given task, which is what we started this whole talk with. In the case of our example, you can easily imagine how most scenarios of our online grocery will focus on shoppers and their experience and not concern themselves with how the products actually made their way into the system. However, we should not neglect the needs of our admin staff, which is what very often happens now when we create software systems. And we should also have some tests that verify those admin UIs that we not normally use in the regular test. So how do we actually do that without risking duplicating code and effort? Well, you guessed it, we create alternative implementations. And since you already know how to write Serenity.js tasks, just know task where API, that is it. You already know it. Done. That's your training complete. You can get a certificate from me after the talk. Oh, you're still not asleep. Very good. Now, what you do to create this alternative implementation is you simply compose it from other alternative interactions. So in this case, we could have an implementation that goes through the API. We could have an implementation that goes through the UI. And depending on the scenario, we can pick one or the other. Because what we focus on what this specific task helps us to accomplish. Now, the other advantage of this approach is that by focusing on specific tasks in our domain, we really limit the blast radius of any changes that might normally impact our test suites. For example, if our business changes the definition of how tasks are being performed, what we do is we simply change the implementation of this given task. And any other scenario that uses this task will automatically work. We don't have to change all the tests in our test suite. And how do you make an actor perform web interactions on top of the API ones? Again, the exact same pattern applies, and you already know it. So all you do is you give the ability to browse the web with your favorite web integration tool, like WebDriver.io. Thanks, Christian. And you make your tasks interact with the UI instead of the API. Now, you might have noticed that every actor can have multiple abilities. So you can make one actor interact with multiple interfaces. You can have an actor per interface. It really depends on what makes more sense in your domain. But now, the moment that many of you have been waiting for, okay, how do you actually implement an interaction with a web UI? And I'm worried that there's absolutely no magic here involved whatsoever. All you do is you simply import task to enter the value into the field, click on a button, submit in the form field. It really is that simple. It's just a different interface. Now, Serenity takes this idea of functional composition and code reuse to a whole new level. So not only you can write tasks interacting with any interface using the same consistent pattern that you already know, Serenity.js enables you even to compose and reuse your page element selectors in a type-safe way. But that's a story for another time. And you can read more about this whole idea of Serenity.js page element query language on the Serenity.js website. But for now, let's quickly summarize the ideas and patterns that we talked about. So you can do blended testing like a pro with Serenity.js. Now, first and foremost, to do blended testing in a safe and scalable way, you must be able to swap out one type of interaction for another type of interaction. To do that, you need to know what they do, so you need to focus on the goal that they help to accomplish. Now, the easiest way to do it is to focus on your actors and your business domain and their tasks. And we do that by borrowing some ideas from user-centered design. Now, since tasks are focused on the goals that they accomplish, like find a product or enable a deal, you can use them as an abstraction to provide alternative implementations, which lead to the same outcome. Now, this means that you can replace some parts of your workflow, typically dedicated to data setup or progressing your system to a desired state that would normally interact with the UI, and make them interact with REST APIs or a database directly. Now, this obviously simplifies the scenario and improves the overall performance, reliability, and stability, because we're reducing the amount of interactions. Now, apart from that, Serenity helps you model your code using functional composition. So you can create functions that are easy to understand, identify, and reuse. And you've already learned how to do it. And since there are standard JavaScript functions returning a task object, what you can do is you can easily bundle them into node modules. And you can reuse them across test suite, across projects, across teams. They're just code, and it's very easy to reuse. Now, another great thing about this model is that it makes it very easy for you to create targeted tests. So you can have some of your end-to-end tests take a shortcut, go through the API, but some of those tests could go to the UI, right? And it's very easy to see which one is doing what, because all you need to do is you need to go to your IDE, your IntelliJ, or WebStorm, your VS Code, just find usages of a function. Now you know what tests do what. Very easy. But it is your choice to decide what interface you want to interact with. This is not something that's forced upon you by your integration tool. So this way you can have both the speed and stability without sacrificing the coverage, because you can always add specific targeted tests. And all that without code duplication, because your code reuse model operates at the task level, not at the scenario level. And all those test suites can reuse the same portable tasks. Now, Serenity provides integrations with popular test runners like Cucumber, Mocha, Jasmine, Playwright Test, and so on, as well as popular API and web integration tools. So again, we have integrations with Playwright, with Puppeteer, with Selenium, with WebDriver.io, and though there are more integrations coming soon. But that's not all. When you need to, you can actually create your own integrations if you need. That's not a problem, it's an open model. Now, the cool thing about this consistency of the design pattern and the consistency of APIs is that once you tell Serenity what each task is doing by saying task where actor sets the product price, well, Serenity knows that this is a task where the actor sets the product price. So it can produce a test report that says exactly that. So now you have not just the code that is expressed using your domain language that everybody on your team can understand, the testers, the developers, the business owners, and so on. You have test reports expressed using the exact same language that is specific to your project and your company. And of course, you are the best person to describe and define what this language should be. Well, you can learn more about Serenity.js and Screenplay Pattern and blended testing at serenityjs.org. And if I didn't mess up anything, this QR code should work. All right, so if you are okay to invest 15 minutes in learning Serenity and the Screenplay Pattern, we have a new tutorial that you can run in your browser with no local installation required, thanks to gitpod.io. My name is Jan Molak, and thank you so much for having me. If you have any questions, please ask. And I believe you are going to get a microphone. But please don't ask me about how I broke my microphone, because I'm not sure.
Okay, we'll not do that. Hi, Jan. Thank you so much for presentation. My question is, why it's called Screenplay Pattern? Because all the years I've been working in UI testing, it's been called behavior-driven testing.
Oh, yeah. So as you might have noticed, I'm actually quite into behavior-driven development and behavior-driven testing. So those are all the same ideas. So we called it the Screenplay Pattern to amplify the metaphor of a stage performance and to help people think in this way. So we have actors perform on a stage. They have certain things that they use, they have certain other actors that they interact with, and it's just a helpful way to kind of detach ourselves from thinking about a test from the perspective of a test integration tool. Well, if you think about it, you can use it to describe your test as you would to a human being. That's what you do in a scenario. You are the actor. Does this answer the question?
Somewhat. It seems like rebranding, but that's okay. Another question I had, we did try Cucumber, and I believe Serenity.js as well. So the problem that we were facing is not about reading test and understanding what it does. How do we know what method we should be using to write another test? Because it's the domain-specific language that we introduced. It doesn't have support from development environment. So our conclusion was it's just really hard to use it unless you have very small application that has very little functionality.
So if I understand correctly, the question is, how do you know what to write in your test?
Yes, how do you solve the problem of helping a developer who's building a test to understand which methods he or she should be using? How to use this domain-specific language that we introduce in with this approach?
Oh, that is a very good question. Well, the challenge with that is to know what to write in your test. You need to know how your business works. You need to know what workflows you have. You need to know what actors you have. And there are many different ways to do it. So, for example, to figure out what actors you have, well, you could suggest to developers or testers to work with your user experience people. Perhaps they already have some personas or a concept of a market segment that uses this system. This might be your actors. That's one idea. So I would start by trying to identify the actors in a scenario. and trying to figure out what is exactly the outcome that they are after, and then how they are going to go about accomplishing this outcome. Now, you could go from outside in, so as I just described, you could go from inside out. So if you have a legacy system, you would actually start with all your low-level clicks and sends of your post requests and so on, and then try to extract tasks that make sense, so group them up. So either chunk it down or chunk it up.
Thank you, Jan.
You're welcome. Okay, we have one more question. And if that one last question is when is lunch, I believe it is now. Thank you so much for having me. It's been a great pleasure. Thank you.